Hello students, myself Amrita Dhar, Assistant Professor of Electrical Engineering Department of Greater Kolkata College of Engineering and Management, JIS Group. Now, I will teach you switchgear and protection.
In this video, I will discuss about protection against lightning. In the previous video, I have discussed about different causes of overvoltage. Lightning is the major cause of overvoltages in the power system. Now, we also discussed about the mechanism of lightning, different strokes of lightning. In this video, we discuss about protection against lightning. This topic is included in Module 5 of the subject Switchgear and Protection. Subject code is EE/S5/SWGRP. So let's start. Now, transients or surges on the power system may originate from switching and from other causes, but most important and dangerous surges are those caused by the lightning. The lightning surges may cause serious damage to the expensive equipment in the power system, either by the direct strokes on the equipment or by the strokes on the transmission lines that reach the equipment as traveling waves. It is necessary to provide protection against both the kind of surges. The types of protection, the most commonly used device for protection against lightning surges are earthing screen, overhead ground wires, and lightning arrestors or surge drivers. There are a lot of lightning arrestors. Each have their own advantages and disadvantages. We will discuss one by one. Now first we discussed about earthing screen. The power station and substation generally house expensive equipment. This station can be protected against direct lightning strokes by providing earthing screen. It consists of a separate of copper conductor, generally called shield or screen, mounted all over the electrical equipment in the substation or power station. The shield is properly connected to earth on at least 2 points through a low impedance. On the occurrence of a direct stroke on the station, screen provides a low resistance path by which lightning surges are conducted to ground. In this way, station equipment is protected against damage. The limitation of this method is that it does not provide protection against the traveling waves which may reach the equipment in the station. Next, overhead ground wires. The most effective method of providing protection to transmission lines against direct lightning strokes is by use of overhead wires. For simplicity, one ground wire and one line conductor are shown. Now the ground wire are placed above the line conductor. This is the line conductor and this is the ground wire. Ground wire is placed above the line conductor. The ground wires are placed above the line conductors at such position that practically all the lightning strokes are intersected by them. The ground wires are grounded at each tower or pole through a low resistance as possible. Due to their proper location, the ground wire will take up all the lightning strokes instead of allowing them to line conductors. Now, when direct lightning strokes occur on the transmission line, it will be taken up by the ground wires. The heavy lightning current from the ground wire flows to the ground, thus protecting the line from the harmful effects of lightning. It may be mentioned here that the degree of protection provided by the ground wire depends upon the footing resistance of the tower. Suppose, for example, tower footing resistance R1 ohm and the lightning current from the tower to ground is I1 ampere. Then the tower rises to a potential V1 is given by V1 equals to I1 R1. To a potential Vt is given by Vt equals to I1 R1. Since Vt is equal to I1 R1, since Vt is approximate voltage between tower and the line conductor, this also voltage will appear across the string of the insulator. Now, if the voltage of Vt is less than required to the cause insulator flashover, no trouble results. On the other hand, if Vt is excessive, the insulator flashover may occur since the value of Vt depends upon the tower footing resistance R1. The value of this resistance must be kept as low as possible to avoid the insulator flashover. Now, what are the advantages of this system? It provides considerable operation against the direct lightning strokes on transmission line. Second, a grounding wire provides damping effect on any disturbance traveling along the line as it acts as a short-circuited secondary. Third, it provides a certain amount of electrostatic shield against the external fields. Thus, it reduces the voltage induced in the line conductor due to discharge of a neighboring cloud. Disadvantages. What are the disadvantages? It requires additional cost. Second, there is a possibility of its breaking and falling across the line, thereby causing a short circuit fault. This objection has been greatly eliminated by using galvanized stranded steel conductor as ground wire. This provides sufficient strength to the ground wires. Lightning arrestor. The earthing screen and the ground wires can well protect the electrical system against direct lightning strokes, but they fail to provide protection against lightning waves which may reach the terminal apparatus. The lightning arrestor or surge diverters provide the protection against such surges. What is the definition of lightning arrestor? A lightning arrestor or a surge diverter is a protective device which conducts the high voltage surges on the power system to ground. Now, in the first figure, this is the basic form of a surge diverter. It consists of a spark gap in series with a nonlinear resistance. This is the spark gap, and it is connected in series with the nonlinear resistance. One end of the diverter is connected to the terminal to be protected, and other end is effectively grounded. The length of the gap is so set that normal line voltage is not enough to cause an arc across the gap, but a dangerously high voltage will break down the air insulation and form an arc. The property of nonlinear resistance is that resistance decreases as the voltage or current increases and vice versa. Now, this is clear from the volt ampere characteristics of the resistor. Now, the function of lightning arrestor or surge diverter. First, under normal operation, the lightning arrestor is off the line, that is, conducts no current to earth, or the gap is non-conducting. Second, on the occurrence of overvoltages, the air insulation across the gap breaks down and an arc is formed, providing a low resistance path for the surge to the ground. In this way, the excess charge on the line due to surge is harmlessly conducted through the arrestor to ground instead of being sent back over the line. Third, it is worthwhile to mention the function of nonlinear resistor in the operation of arrestor. As the gap sparks over due to overvoltages, the arc would be a short circuit on the power system and may cause power follow current in the arrestor. Since the characteristics of the resistor is to offer high resistance to high voltage or current, it prevents the effect of a short circuit. After the surge is over, the resistor offers high resistance to make the gap non-conducting. Now, in this way, the lightning arrestor is functioning. Two things must be taken care of in the design of a lightning arrestor. Firstly, when the surge over the arc in gap should cease. If the arc does not go out, the current would continue to flow through the resistor and both the resistor and gap may be destroyed. Secondly, IR, where I is the surge current across the arrestor when carrying surge current, should not exceed the breakdown strength of the insulation of the equipment to be protected. Next is the types of lightning arrestor. There are several types of lightning arrestor in use. They differ only in constructional details but operate on the same principle, that is providing low resistance path for the surges to the ground. Now different types of lightning arrestors are rod gap arrestor, horn gap arrestor, multi-gap arrestor, expulsion type lightning arrestor and volatile lightning arrestor. Each of these arrestors have its own advantages and disadvantages. First we start with rod gap arrestor. Now it is very simple type of diverter and it consists of two 1.5 centimeter rod which are bent at 90 degree with a gap in between, as you can see in this picture. These are the rods which are bent 90 degree and a gap of 1.5 centimeter. One rod is connected to the line and the other rod is connected to the earth. This rod is connected to line and this rod is connected to earth. This rod is connected to transformer tank and transformer tank is earth. So this rod is connected to earth. The distance between gap and insulator, that is distance P, must not be less than 1/3 of the gap length so that the arc may not reach the insulator and damage it. Generally, the gap length is so adjusted that breakdown should occur at 80% of spark over voltage in order to avoid cascading of very steep wavefronts across the insulator. The string of insulators for an overhead line on the bushing of transformer has frequently a rod gap across it. Under normal operating condition, the gap remains non-conducting. On the occurrence of a high voltage surge on the line, the gap sparks over and the surge current is conducted to earth. In this way, excess charge on the line due to surge is harmlessly conducted to earth. So under a normal operating condition, this gap is non-conducting, and under fault condition or under lightning stroke, this path is conducting. Now there are limitations of this type of arrestor. First, after the surge is over, the arc in the gap is maintained by the normal supply voltage, leading to a short circuit on the system. That means surge is over, but the rods may melt or get damaged due to excessive heat produced by the arc. The climate condition, that is rain, humidity, temperature, affect the performance of the rod gap arrestor. The polarity of the surge also affect the performance of this arrestor. Now due to this limitation, the rod gap arrestor is only used as the backup protection in case of main arrestor. Next is the horn gap arrestor. Now there are two metal rods A and B, looks like a horn and separated by a small air gap. The horns are constructed, the distance between them gradually increase towards the top. The horns are mounted on the porcelain insulator. One end of the horn is connected to the line through a resistance R and choke coil L. While the other end is effectively grounded, the resistance R helps in limiting follow current to a small value. The choke coil is so designed that it offers small reactance at normal power frequency, but a very high choke coil is so high reactance at the transient frequency, thus the choke does not allow the resistance to enter the apparatus to be protected. The gap between the horns is so adjusted that the normal supply voltage is not enough to cause an arc across the gap. Under normal operating condition, the gap is non-conducting, that is normal supply voltage is sufficient to initiate the arc between the gap. On the occurrence of a voltage, spark over takes place across the small gap G. The heated air around the arc and the magnetic effect of the arc causes the arc to travel up the gap. The arc moves progressively into position 1, 2 and 3. At some position of the arc, that is position 3, the distance is too large to maintain the voltage, to maintain the arc. Consequently, the arc is extinguished and the excess charge on the line is thus conducted through the arrestor to the ground. That's why the distance is increasing in such a way that the voltage is not enough to maintain the arc. But this arrestor has also advantages and disadvantages. Advantages are the arc is self-clearing, therefore this type of arrestor does not create a short circuit of the system after the surge is over, and series resistance helps in the limiting the follow current to a small value. So in the first point, it overcome the drawback of the rod gap arrestor. Limitation: the bridging of the gap by some external agency, that is bird, can be rendered the device useless. The bird touch both the rod, then this equipment is useless. The setting of the horn gap is likely to change due to corrosion or pitting. This adversely affects the performance of the arrestor. The time of operation is comparatively long, say about 3 seconds, in view of the very short operating time of modern protective gear. For feeder, this time is far. So due to this limitation, this type of arrestor is not reliable and can only be used as a second line of defense like the rod gap arrestor. Next is the multi-gap arrestor. Now this figure shows the multi-gap arrestor. It consists of a series of metallic cylinders insulated from one another and separated by small intervals of the air gaps. A in the series is connected to the line and the other ground through a series resistance. Other end is connected through ground through a series resistance. Series resistance limits the power arc by the inclusion of series resistance. The degree of protection against traveling waves is reduced. In order to overcome this difficulty, some gaps, that is BC, are shunted by the resistance. BC are shunted by the resistance. Under normal condition, the point B is at arc potential and the normal supply voltage is unable to break down the series gap. On the occurrence of an overvoltage, the breakdown of series gap A and B occurs. The heavy current after breakdown will choose the straight through path to arc via the shunted gap B and C, instead of the alternating path through the shunt resistance. When the surge is over, the arcs B to C go out and any power current following the surge is limited by the two resistance, shunt resistance and series resistance, which are now in series. The current is too small to maintain the arcs in the gap A to B and normal condition are restored. Such arrestor can be employed where system voltage does not exceed 33 kV. Next is the expulsion type arrestor. This type of arrestor is also called protector tube and is commonly used on the system operating at voltage up to 33 kV. Now this figure shows the essential parts of a expulsion type largening arrestor. It consists of a rod gap A dash in the series with a second gap enclosed within the fire tube. The gap in the fire tube is formed by the two electrodes. The upper electrode is connected to the rod gap and the lower electrode to the arc. One expulsion arrestor is placed under each line conductor. Now on the occurrence of an overvoltage on the line, the gap A dash is spanned and an arc is trapped between the electrodes in the tube. The heat of the arc vaporizes some of the fire of tube walls, resulting in production of a neutral gas. In an extremely short time, the gas builds up high pressure and is expelled through the lower electrode, which is hollow. As the gas leaves the tube violently, it carries away ionized airs around the arc. This deionizing effect is generally so strong that arc goes out at a current zero and will not be re-established. The advantages are they are not very expensive. Second, they are improved form of rod gap arrestor as they block the flow of power frequency for follow currents. They can be easily installed. And what are the limitation? An expulsion time arrestor can perform only limited number of operation, as during each operation some of the fiber material is used up. Second, this type of arrestor cannot be mounted in an enclosed equipment due to discharge of gases during operation. Third, due to poor volt ampere characteristics of arrestor, it is not suitable for the protection of expensive equipment. Next is the valve type arrestor. Valve type arrestor incorporate non-linear resistors and are extensively used on power system operating at high voltages. Now this figure shows the various parts of the valve type arrestor. It consists of two assemblies, spark series gap and non-linear resistors disc in series. Both the assemblies are accommodated in the tight porcelain container. Now the spark gap is a assembly consisting of a number of identical spark gaps in series. Each gap consists of two electrodes with a fixed gap spacing. The voltage distribution across the gap is linearized by means of additional resistance elements called grading resistors across the gap. The spacing of the series gap is such that it will withstand the normal circuit voltage. However, an overvoltage will cause the gap to break down, causing the surge current to ground via nonlinear resistor. The nonlinear resistor discs are made of inorganic compounds such as thyrite or metrocil. These discs are connected in series. The nonlinear resistor have the property of offering a high resistance to current flow when normal system voltage is applied, but a low resistance to current to flow the high surge current in case of a lightning strikes. In other words, the resistance of these nonlinear elements decreases the increases in the current through them and vice versa. Now, how it operates under normal operating condition, the normal system voltage is insufficient to cause the breakdown of air gap assembly. On the occurrence of an overvoltage, the breakdown of series spark gap takes place and the surge current is conducted to earth via nonlinear resistor. Since the magnitude of surge gap is very large, the nonlinear elements will offer at a low resistance to the passage of surge. The result is that the surge will rapidly go to earth instead of being sent back over the line. When the surge is over, the nonlinear resistor assume high resistance to stop the flow of current. Now, what are the advantages? They provide very effective protection against surges. They operate very rapidly, taking less than a second. The impulse ratio is practically impunity. What is impulse ratio? Breakdown voltage under surge condition by breakdown voltage under low frequency condition. What are the limitations? They may fail to check the surges of very steep wavefront from reaching the terminal apparatus. This calls for additional steps to check steep fronted waves. Their performance is adversely affected by the entry of moisture into the enclosure. This necessitates effective sealing of the enclosure at all times. Applications. Now, according to their application, the valve type arrestor classified as station type and line type. The station type arrestors are generally used for protection of important equipment in the power station operating on voltage up to 220 kV or higher, and the line type arrestor used for station handling voltage up to 66 kV. Next is the surge absorber. The traveling wave set up on the transmission line by the surges may reaches the terminals apparatus and cause damage to it. The amount of damage caused not only depends upon the amplitude of the surge but also upon the steepness of its wavefront. The steeper the wavefront of the surge, the more the damage caused to the equipment. In order to reduce the steepness of wavefront of a surge, we generally use surge absorber. A surge absorber is a protective device which reduces the steepness of wavefront of a surge absorbing by absorbing the surge energy. Now, although both surge diverter and surge absorber eliminate the surge, and the manner in which it is done is different in the two devices. The surge driver diverts the surge to earth, but the surge absorber absorbs the surge energy. Now, there are few cases of surge absorption. In the first figure, a condenser connected between the line and the earth can act as a surge absorber. Now, since the reactance of the condenser is inversely proportional to frequency, it will be low at high frequency and high at low frequency. Since the surges are of high frequency, the capacitor accesses short circuit path and passes the lightning strokes directly to the earth. Now, however, the power frequency, the line reactance of the capacitance is very high and practically no currents flow through the ground. In the second figure, here is a parallel combination of resistance and inductance. Now, the resistance offer high reactance of such frequency because we all know XL is equal to 2 pi FL. So, if F is high, XL is high. So, the surges are therefore forced to allow through the resistance where they are dissipated. In the third figure, this type of surge absorber is called Ferranti surge absorber. It consists of a air-cooled inductor connected in series with the line. The inductor is surrounded by but insulated from earth metallic sheet called dissipator. This arrangement is equivalent to a transformer with the secondary short-circuited. The inductor forms the primary where the dissipator forms the secondary short-circuited. The energy of the surge is used up in the form of heat generated in the dissipator due to transformer action. This type of surge absorber is mainly used for the protection of the transformer. Now, this figure shows the schematic diagram of 66 kV Ferranti surge absorber, and this shows the equivalent circuit of this Ferranti surge absorber.
That's all from today's class. If you have any problem, please contact with me. My contact details is given on the first slide. Thank you.